Okay, today we're going to work on lesson 4 in unit 1, and today's lesson is called Parallelograms, and we're going to learn a little bit more about what is a parallelogram, and of course then we're going to explore area and parallelograms. All right, so to start out with, what do you notice? What do you wonder? Pause the video, and as a group, I would like you to talk about what do you notice and what do you wonder? Okay, hopefully you paused the video and you guys had a discussion. I'll just share some of the things. That's why I have these notes right here so I can kind of share some of the things. All except one figure, which is figure E, they all are quadrilaterals. Quadrilaterals is a figure with 4 sides. Figures C and E, so C and E, all of the side lengths are the same. Then it says B and C are rectangles. Now I know some of you would say that C is a square. A square is a special type of rectangle. Some things you might wonder is like, why is there a hexagon in this set? If the sides of figure A are all equal, you might be wondering that. Does this side equal this side? Not quite sure. And maybe is figure C a parallelogram? If you know what a parallelogram is, that's a question you might ask. Okay, so let's move on. Now what I would like you to do is to answer these 3 questions. And as you ask each question, you're going to pause the video and talk among yourselves. You don't have to write anything down. You just need to talk. And everybody should be contributing. So figures A, B, and C are parallelograms. Figures D, E, and F are not parallelograms. So the top row are parallelograms. The bottom row, they are not parallelograms. So what do you notice about the sides, the number of sides that a parallelogram has? Pause the video. Okay. What do you notice about the opposite sides of a parallelogram? Pause the video and talk. And finally, number 3, what do you notice about the opposite angles of a parallelogram? So if we're looking up here at A, this angle and this angle are opposite of each other, and this angle and this angle are opposite of each other. Pause the video and talk about that. Okay, so we're going to actually jump right into what is the definition of a parallelogram. A parallelogram is a type of quadrilateral, right? That word quad, again, quad means 4. So it's a type of quadrilateral, a 4-sided figure that has 2 pairs of parallel sides. So in this first figure, this top line and the bottom line are parallel. And this side are parallel. The 2 sides have the same, what would you call it? Kind of like the same tilt, right? If we were to run those lines forever, if we were to run this line forever and this line forever, they would never meet. And that's what parallel lines are. Again, on this figure, the top side and the bottom side are parallel. And this side and this side is parallel. You will also notice that the 2 parallel sides are the same length. So this top and bottom are both 5, and the sides are both 4.24. Also notice that opposite angles in a parallelogram are the same. So this angle is 27.2 degrees, and so is this one. So opposite angles are equal, opposite sides are equal, 4 sides and 2 pairs of parallel sides. Okay, quadrilateral, we already said it. It's 4 sides. So why was the pentagon not a quadrilateral? That's because a pentagon or a hexagon, I think, did I call it a pentagon? A pentagon only has 5 sides. A hexagon has 6 sides. So they would not be quadrilaterals. Sorry if I called it a pentagon earlier. Alrighty, we are going to move on into the next activity. So we're going to reflect on these questions. Why did you decompose the parallelogram the way you did? That was a word, a vocabulary word that you should have looked at in the summaries of lesson 2 and 3. But it basically means that we kind of chop up the parallelogram and rearrange the pieces in order to find the area. So think about this, think about numbers 1 and 2, and how could you sort of cut the parallelogram and then rearrange it to form a rectangle? Because we know how to find the area of a rectangle. So pause the video for a moment and you can work together and see how you might chop this up and create 2 rectangles out of these. Okay, so I have this little applet to show you that I have this parallelogram, and I can take this piece and put it in. I can take this piece and put it in. And then I could take this piece and put it in. And you can see that it's completely filled in. Now I'm going to move this piece out of the way. And that's my dishwasher if it's really loud, sorry. So I'm going to take this first piece that I put in and I'm going to chop or cut or decompose my parallelogram by moving, whoops, not that piece, by moving my red piece. It doesn't want to move. All right, hang on. Let me move that just a wee bit. And I'm going to move this red piece to the other side. I'm going to move that blue piece back. Okay, once I take that red triangle out, decompose it, and move it over here, you can see that I've actually created a shape that is, it kind of looks like a square. And I can find the area now of this parallelogram. So I can see that there's 1, 2, 3, 4, 5, 6 squares on top, and 1, 2, 3, 4, 5, 6 squares along the side. So the base, which is down here or up here, is 6. So the base is 6 and the height is 6. 6 times 6 is 36. So I have found that the area of this parallelogram is 36. And it doesn't really matter if I've cut off this piece. Really what we're trying to do is to show you that the parallelogram is made of these different pieces. And when you rearrange them, you can turn it into a rectangle or a square. And that's how you can find the area of that shape. Okay, so hopefully you guys did that for both of those. I'm not sure if this is the second one or not, but it's the same idea. You just cut off part, rearrange it, and then you can find the area. Okay, so let's move on to activity 4.3. I'm just going to tell you ahead of time, we are not going to work with this shape here just yet. Decomposing that shape is difficult and there's a different strategy that you could use, but I'm going to just focus on A and C. So what I would like you to do is pause the video and try to find the area of A and C. Okay, hopefully you paused the video and you have spent some time working on that and you can talk to each other about it. Let's talk about over here on the side what one strategy is. So I could actually take off this bottom piece that looks like a triangle and decompose, move it up and compose, put it back together, and then I will have created a rectangle. And so then I can see that my rectangle has a base of 3, either at the top or the bottom, and a height of 5. So base times height means that the area of this rectangle or the area of this parallelogram is 15 square units. Second, we're skipping B, so we're going to go over here and look at C. So we can do the same thing. They have shown you with this little dotted line that you can chop it off right there, decompose it, and move it to the other side. So I'm going to show you with this one. You can take that piece, move it over to the other side, and then you'll see that the height is 4. And if you go back to your original diagram, this dotted line, the height is 4. The base is 6. So if the height is 4 and the base is 6, that means the area of our parallelogram is 24. All right. So you guys hopefully have talked to each other about that. We're just going to go quickly through the synthesis. Parallelogram has 4 sides. The opposite sides of a parallelogram are parallel. The opposite angles of a parallelogram have equal measure. The opposite sides have equal length. I just said that backwards as to what it's showing you, but you get the idea. Okay, parallelogram is a type of quadrilateral that has 2 pairs of parallel sides. Here are 2 examples. Alrighty, so if you are ready, this is your cool down. You can come get it in paper form and take the cool down. If you feel like you need some more practice, you can go ahead and do some of the practice problems, and I'll give you the answers to those to see if you're on the right track. All right, good job, guys.